What's going on, everyone? This is Jay Patel, and in this video we are going to code what we studied in the previous video, which is about training word embedding. So in this video we are going to write a program completely from scratch in Python to train word embeddings. If you haven't watched my previous video yet, then you can do so by clicking on the upper I button, or you can also find the link down in the description box. So what we are going to do in this video is that we are going to first load this text, which will act as our data set. And from this sentences, we will train our word embeddings. We are going to follow these 5 steps, which is first we'll load the data, create bigrams. So after we create the bigrams from the data set, it will look something like this. Then we are going to perform one-hot encoding of the individual word. So every word will be converted into one hot vector. Then we are going to create a model and train the model and then visualize the results. If you want to follow alongside with me, then you can find a link to the GitHub repo down in the description box. Once you open that GitHub, you can click on this template code, which will take you to this Jupyter notebook, which is a blank Jupyter notebook. Here you can write code alongside with me. And you will also find my complete code in this repository. And in this video, I'm going to show you a complete Python code from scratch. I'm not going to use any built-in library, I'm not going to use any built-in library except for the neural network, which we are going to create using Keras. So if you're very good with Python and if you don't want to know how these texts are processed and how bigrams are created, then you can directly skip to the timestamp where the model is created. But anyways, I feel if you follow this entire video, it's going to be a very informative video because this is what you deal. Now, and this is the similar code that I used to train or fine-tune word embeddings that I needed for one of my project. Apart from this, at the end of the video, I will also share you some very useful tips about dealing with word embeddings. And also at the end of the video, I'm going to share you very useful details regarding word embeddings. So make sure to stick till the end. And before we move further to this video, you have to subscribe to my channel. So hit the red subscribe button. And once you have subscribed to my channel, let's get started with coding. So first we are going to load our data. Loading is simple. I'm just reading the file. I'm going to store this content into a variable named royal data. So I'm just reading the file with file.readlines. It's just simple Python command to read files. Then I will close file. And let's print how our royal data looks like. So these are the sentences. Now I'm going to convert this sentence into lowercase, and I'm also going to remove this next line character. And because we want to convert this sentences into lowercase to remove the stop words and also tokenize the sentence. Tokenize the sentence means we extract the individual words and store them into a list. So what I'm going to do is I'm going to run a for loop over royal data, and every sentence in it will be converted to lowercase, and I will replace that next line character with nothing, basically removing that next line character. So if I print royal data, you will see that the sentence is converted to lowercase and next line character is removed. Now we will remove stop words from this sentence, and we are also going to tokenize the sentence. So stop words are the words that occur often in a language but does not carry any meaningful information for our model. So these words are like the, is, are, can, etc. So I will list some of the stop words that are present in our data set, which we are going to remove. Now I will store the filtered data into a variable filter data, which will be first an empty list. Now this list will store our tokenized sentences after we have removed the stop words. So again, I'm going to run a for loop in royal data, and I will tokenize the word. So if I write for word in send.split will tokenize every words, which means if I print word now, you will see that all the words are splitted into tokens. Now I will now to remove the stop words, what I'm going to do is I'm going to create another list, which will be a temporary list. And in that temporary list, I will store the word if it is not in our stop words list. So if the word is not in this list, then store that into temporary list. Now this temp list will store a single tokenized sentence. So I'm going to append all those sentences into our filtered data. So you can see that every sentence is converted into tokens and stop words are also removed. Now this is our single sentence, and from every single sentence we are going to create bigrams. I will store those bigrams into a list. Also, to maximize the number of bigrams that we can have to train our model, what I'm going to do is I'm going to take all the combinations of bigrams that I can extract from a single sentence. For example, this single sentence has 3 words, so total number of combinations that we can obtain from this is 6, which is taking any 2 words at a time, right? And I'm also going to flip those words after taking those words. So for example, my one bigram can be future king, then I'm going to flip that, and the other bigram will be king future, and then a third bigram can be future prince, then I'm again going to flip that bigram, that will be prince future, and so forth. So for that, first we will need to iterate over the single sentences from this list. So I will name this as word list. And then from this list, I'm going to run 2 for loops to get all the combinations of the bigrams. So the I will iterate from the beginning till the last second character in the list, and J will iterate from the next token of the I till the last word in the list. This is just a simple code for getting permutations of bigrams. Then I will append both the combinations. First word list I and then J, and then the reverse of this, which means that the first J and then I. Now if I print bigrams, also I just forgot to wrap these 2 words in a list, so I will do that. So here we can see all the bigrams, as I said, future king, king future, future prince, prince future, and so forth. So these are all the bigrams which will act as our input data to our model. Also, if you don't understand this logic, just look at it. Here I've just created 2 pointers I and J. The first pointer will loop from the starting till the last second character, and the second pointer will start from the I+1 and till the last character. So we get all the combinations of words. Now we will create our vocabulary, which I will name as all words. So this will be our vocabulary in which we will identify all the unique words that are present in our dataset. Now to get all the unique words that are present in our dataset, I'm going to combine or merge all these words into a single list, and then I'm going to convert that list into a set, which will give us all the unique words. So this is our filtered data. So I will create another list which will just combine all these words into a single list. So for sent in filtered data, just extend all words with the sent. Now if you do not know what is extend just extends the list. So if I print all words, extending a list means whatever list we pass, it adds all the element of that list into that list. Now I will convert all words into a set. Now this is a set, and thus we will have unique words. Now I'm going to also convert this set back into list, because we want to deal with list and not set. So these are all the unique words that are present in our vocabulary. Let's see how many number of unique words do we have. So we have 12 number of unique words. Also, we should sort this list. Sorting is not necessary, but just to have a better visualization, let's sort this list. So we have followed 2 steps, that is loading our data, converting, creating bigrams. Now we will move on to our 3rd step, which is to perform one hot encoding. So let's perform one hot encoding. Before we directly create one hot encoding, let's also assign every word a single token. That is the order at which they appear in our vocabulary or in our dictionary. So we will create a Python dictionary for that, which I will name it as word dict. So for every word in our all words, Words2Vec will assign that word a token which I'm going to name as a counter. I will start the counter with 0 and increment it every time. So our words dictionary looks something like this, which means that every word has now a token associated with it. And based on this token, we are going to create one hot vectors. And for the same, I'm going to import numpy because we will need that. Now we will create an entire one hot data that will consist of a matrix with all the words in it converted into one hot vectors. I'm going to initialize that with np.zeros, and and the size of it will be equal to the length of our all words, comma, length of again our all words. Now why so? Because if you see, this data will have all words, right? And the size of one hot vector is also equal to the number of words that are present in our vocabulary. So that should be equal to 12 by 12. And then I'm going to assign, one at the position where these words word token are located. So for I in, which means that we just want to create a matrix where there is a 1 at a position where these words are located into that vector. What do I mean is that if I print one hot data, you will see this identity matrix, because this single row that you can see is a one hot vector for our word beautiful. The second row that you can see is the one hot vector for our word boy, and so forth. Now I will also create one hot dict so that it can also be used. Now one hot dict will be a dictionary that will map the words to this one hot vectors. So that will be created for I in range length of all words. And one hot dict, I will pass key value, that is we want to map every word to this one hot vector for that corresponding word. So if I print this dictionary, I will print this in a nice form. You will see something like this. I will erase the above print. I will comment this about print so that you can see it clearly. So now every word is mapped to that corresponding one hot vector. So we have also created we have also performed one hot encoding. Now we are going to just create our data set that will be created with the help of this Bigrams. So now in this Bigram, every token, every word that we have here will be just replaced by its corresponding one hot vector. So I will name the X input X as X and output label as Y. So every bigrams that are present, what we want is that in X we want the first word of that bigram, and in Y I want the second word. So if I print X, it will look something like this, which means that we have extracted all the first words from all the bigrams and replaced them with their corresponding one hot vectors. To make this even better, I'm going to convert this into a numpy array. And same I'm going to do for Y. Okay, so finally what we have been waiting for, and that is to create our model to train the word embeddings. So as we discussed before, this is how our neural network will look like. In the input layer and the output layer, the number of neurons will be equal to the number of words, unique words that are present in our vocabulary. For us, it is 12, and we can choose the size of the hidden layer. For the simplicity, and for now, I'm going to choose the number of hidden layers as 2, which means that our word embedding vector size will also be 2. I'm choosing 2 because we will use that to plot a scattered graph, which is a 2D graph. So we require 2 dimensions for that. That graph will be useful to understand if our word embeddings are trained properly or not. So I'm going to use Keras to make our model. So I will create a model that will be sequential, and I will add input layer to the model first. Also, I need to import input, and its shape will be equal to 12 comma, because that's the size of our one hot encoding. Then I will add the hidden layer, which is a dense layer of size 2. Now, something to note here is that the activation function that we use for this hidden layer should be linear, which means that we do not want to use any activation function or use a linear activation function. And then the third layer, which is going to be an output layer, will have 12 number of units. Now 12 is again 12 number of units as the size of our vocabulary. Now definitely we should not hardcode these numbers, because these numbers can change if we change our data set. So I'm going to create 2 variables. One is vocab size, and that will be equal to the length of that one hot vector, which I can get by one hot data, any word, and its length. Similarly, I should specify the embedding size here as a variable. I will specify that as 2. So now I will replace 2 with embed size and 12 with vocab size. Also, I forgot to mention that as this is a last layer, we must use softmax activation function here. Now we have the model. Let's just compile the model. The loss will be definitely categorical cross entropy, because we have used softmax activation function. And to speed up the training, I can specify Adam as my optimizer. Let's train our model by calling model.fit. We pass our input data and output label y, and the number of epochs that we specify are, let's say, 1000 for now. So our model has been trained for 1000 epochs. Now all we need to do is just extract the weights, which will act as our word embeddings. So to extract the weights, we use this command get weights. Now if you print weights, you will see all the weights that are present in the model. For example, these weights that you see are the weights between the hidden layer and the output layer, and these weights that you see are the weights between the input layer and the hidden layer. We want these weights that are between hidden and the output layer, so we will extract these weights by specifying index 0 here. Now I'm going to create word embedding dictionary to map word with their corresponding embedding. Every word will be mapped with their corresponding weight value. This is the word embedding for the word beautiful. I want the token number for the word beautiful, which I will get by our words dict. Let's print word embeddings dict, and let's see the result. Oops, it should be weights, and this should be word embeddings. Okay, so we have our word embeddings. Let's print this in a nice form. So we have our word embeddings that are trained, but how do we check if these are working properly or not? So let's plot a graph. I will plot a scatter graph. I will plot a scatter plot from using matplotlib. Now this embedding vector will act as coordinates for that scatter plot. So if the two words are close to each other, then they will be plotted close to each other. My coordinates will be this embedding vector, and I need to plot plt.scatter, coordinate 0 and coordinate 1. This should be coordinates, not coordinated. Then I will also assign a label to every coordinate. So that can be done by plt.annotate and specify what text do we want to give to that at that coordinate. So I will assign that text as word, and again specify where do I want to put this text. So that will be again this position. Hopefully this turns out good. So this is the result that I've obtained on my side. You can see that the words like man and woman are close to each other, prince, boy are close to each other, daughter, son are close to each other, which you can say are related. King, queen are related, and that's why they are also close to each other. Now you might see some different result on your side, is because the model randomly initialize the weights first, and based on the random initialization, you might get some different result. Now we cannot say that these are very good results, because the data because the input data that we had was very, very small. We only used handful number of lines to train this model, which you can see here. Now some tips regarding training word embeddings. A good word embedding will have almost all the words that are commonly used in a language, and to obtain that, the data set that we require must contain millions of lines of text, or maybe even billion lines of text. This was the code where we created word embedding completely from scratch in Python. You can also use an inbuilt library to train your own word embedding. One of the famous library for that is called GenSim. You can also use that library to train word embeddings, but I wanted to create a video from scratch, and I've also used the similar code to train or fine tune my word embeddings. Also the word embeddings, here our word embedding vector was of only size 2, but an actual word embedding can be of size 100, 200 or 300. And if you want to use word embeddings in your project, you need not to train word embedding from scratch every time. You can just use pre-trained word embeddings that are already available out there. And that is what we are going to do in the next video. In the next video, we will use word embeddings and also models like LSTM and RNN, and we will create a nice application from that. Also, for some specific application, you might need to fine-tune word embeddings. Now, fine-tuning word embeddings means that we use the pre-trained word embeddings and then retrain them using our data to give these embeddings a context behind the type of application that we are creating. I can give an example. Let's say that you're creating a model that is specific for a certain type of technology. Now, your embeddings might not know a context behind that certain type of technology well. So what you can do is you can take the pre-trained word embeddings and you can fine tune those word embeddings by providing the contextual data related to that technology. So if you want to fine tune them, you can do that with the help of this code as well. What you just have to do is that instead of randomly initializing the weights while training the model, what you have to do is you have to initialize the weights with the pre-trained word embeddings. So I hope this video was helpful for you and you understood all the details about how word embedding works and how they are created. And if you found value from this video, then click on the like button. It will help a lot to me to grow this channel. So that's it for this video, and I will see you in the next one.